Okay, so today we are going to be reviewing for the final exam. Your final exam will open on Wednesday, December 8th in the morning, and it'll be due on Sunday, December, let me make sure, I don't want to get this date wrong. Sunday, December 12th. Okay, it'll be in Math Lab, just like all your other assignments. And what we're doing right now is the final exam review. That I did open for you this morning in Math Lab, so that is open now. So if you wanted to look at it before next week, you could. Okay, let's go ahead and look at number 1. And there's 25 questions. All 25 are multiple choice. Okay, so number 1, graph the following function: g of x equals the absolute value of x plus 2. Now, you could just put this in your y equals, right? You have a graphing calculator. So if you wanted to put this in your y equals, oops. So if you go to your y equals, remember where the absolute value is. If you hit the math button and then go over here to number, the very first thing under number is absolute value. That'll give you those absolute value symbols. And this one is x plus 2. So I'll just put the x plus 2 in there, then right arrow to get out, graph it. So you'll see that it's a V shape, which it's multiple choice, and all the options were V's. So it shifted it 2 places to the left. So the other thing you could have said was, well, there's an inside number. And remember what inside numbers do. They shift you horizontally, left and right, but you go opposite the sign. So that's why that shifted this graph to the left too. Right? Number 2 is finding a function value. Find f of 0 when f of x equals x squared plus 2x minus 5. And it wants me to find f of 0, which means you're just going to go to your function and replace the x's in it with zeros. So if I do that, I will have 0 squared plus 2 times 0 minus 5. And then do the math. 0 squared is 0. 2 times 0 is 0. Bring down that minus 5. So the only thing you're left with is that negative 5. So f of 0 is negative 5. All right, number 3 is determining whether this is the graph of a function or not. Okay, so it's an upside down parabola. And remember what we use. If you have the graph that you're looking at, you use the vertical line test. What the vertical line test tells you is if you can draw a vertical line anywhere and touch it more than once, it's not a function. But on this one, it doesn't matter where I draw a vertical line. I'm only going to touch that upside down parabola one time, which means, yes, this is a function. Okay, just to show you the example of what a not function looks like. What if you had a parabola that went this way? Okay, you'll notice that if you draw a vertical line right here, you would touch the graph once, twice. That is an example of not a function. If your vertical line touches the graph more than once, it's not a function. But the one that's on our review is a function because the vertical line only touches it once. Number 4. Number 4 is solving a systems of equations. You have 5x plus 2y plus z equals -5. (2x minus 4y minus z equals -22, and 2x plus y plus 2z equals 5. Okay, we solve these kind of problems in our matrix function in our calculator. Okay, you're going to make matrix A from the coefficients of the terms that are on the left side of the equal signs. So this one will be, the top row will be 5, 2, 1. The middle row will be 2, -4, -1. The bottom row will be 2, 1, 2. Matrix B will be this column that's on the right side of the equal symbol. So -5, -22, 5. Okay, so let's put this in our matrix function in our calculator. So remember where your matrix is. It's the x to the -1 button, but it's blue, which just means I need to hit the second button first. So second matrix, and make sure you're going over to edit. Once you go over to edit, we're going to edit matrix A. Now mine is already matching this because I've already done this once today, but you need to tell your matrix. Remember, you've got to tell it the order of your matrix first, which is the number of rows by the number of columns. So this one has 3 rows and 3 columns. So you would do 3 enter, 3 enter. And then enter the top row. So 5, 2, 1. The middle row, 2, -4, -1. And then the bottom row, 2, 1, 2. So once you have all that entered, go to second, quit. Right now, back to second matrix again. Back over to edit. Go down to B this time to make your B matrix. So let's see, this one has 3 rows and 1 column. So you need to tell that to your calculator. 3 enter, 1 enter. And then enter the -5, the -22, and the +5. And then quit again. So second, quit. Now, how we solved this is we did matrix A to the -1, matrix B is what solves the equations. So second matrix, matrix A. So go ahead and hit enter to use the A that you created. Then hit that X to the -1 button. And then second matrix, go down to B. So your calculator should have matrix A to the -1, matrix B, hit enter. There is your X, Y, and Z. -3, 3, and 4. All right, number 5 wants to know for this graph to find the range. And the range of a function is its y values. Okay, so it wants to know the bottom, the very lowest point. It wants to know its y and the highest point, its y. Okay, so because it covers all the points in between. So this is the top of it and that's the bottom of it. So the lowest point, and we're going to put these in brackets because the lowest number that is covered, that if you connect this to the y, is -2 on the y-axis. Okay, and you want to put that in a bracket because -2 is in the range. This graph does, this function does touch -2. Its highest point is this one. And you trace it over to the y-axis to see its y value, which is +3. And it does touch that +3, which means we put a bracket around it. So the range is from -2 to 3. Number 6, match the inequality with a graph. You've got 4x minus 3y is greater than -1. So the first thing I need to do, I want to put this in my y equals. So the first thing I need to do is solve it for y. Get the y by itself. So I need to subtract the 4x. Yeah, that's better. So when I subtract the 4x from both sides, on the left, I'm left with -3y is greater than, these two terms are just going to come down next to each other. You can't put them together. They're not like terms. So -4x minus 1. Then you're going to divide both sides, everybody by -3 to get the y by itself. Now, remember, when you divide both sides of an inequality by a negative number, the inequality symbol switches around, okay, which means it's going to go from greater than to now less than. So this negative over negative turns to +4/3 x. Again, negative over negative turns to +1/3. I'm going to put this in my y equals. So go to y equals and clear it out. 4/3x plus 1/3 and graph it. Now I do want to plot points on this. So I'm going to go to my table. So second table and get some good points. I think I'll use that -1, -1, and that 2, 3. So -1 would be to the left 1 and down 1. 2, 3. So to the right 2, up 3. Now remember, when you're graphing an inequality, sometimes the line that connects these 2 points is dashed, and sometimes it is solid. What tells me this is this symbol right here. If it has an equal to bar under the inequality right here, then it's going to have a solid line. If it does not have the equal to bar like this one, then your points are going to be connected with a dashed line. And then you need to do the shading. So this one is less than this line, which means you will shade below the line, which looks like it would match D on this. All right, number 7. This is that ladder problem that we did where we used the Pythagorean theorem, because when you draw out the picture that goes along with this paragraph, it's going to make a right triangle, because it says a ladder is resting against a wall. So here's your wall, here's the ground, here's the ladder. So if your ladder is resting against the wall, the top of the ladder touches the wall at a height of 18 feet. So here's the top of my ladder. So it touches the wall. So this side is 18 feet. Find the length of the ladder. So it wants to know what this side is. If the length of the ladder is 6 feet more than its distance from the wall. So this side is 6 feet more than this side. So this one will be the x, and that one will be x plus 6. So since this does make a right triangle, I can use this Pythagorean theorem to solve for the x. Okay, these two sides are your A and B sides. The side opposite of the right triangle or the right angle is your C side. Okay, so let's see. A squared would be 18 squared plus this side squared, so x squared is equal to this side, so x plus 6 squared. So over here, 18 squared is 324 plus x squared equals, over here I've got x plus 6 squared. So I'm actually going to have to FOIL that. So let's see, x times x gives me x squared. My outer, x times 6 is 6x. My inner is another positive 6x. And then my last 6 times 6 gives me 36. But when I put my x's together in the middle, I have x squared plus 12x plus 36. So that's what the right side of the equal sign is going to look like. X plus 6 squared gave me that. So x squared plus 12x plus 36. Now, it looks like it's going to be quad, but look, notice that here's my equal sign. I have x squareds on either side of the equal sign, so why not just subtract them off? That will cancel both of them, right? I can do anything I want as long as I do it to both sides. So if I subtract that x squared from both sides, I don't have an x squared anymore. It's not quad. I'm just left with 324 equals 12x plus 36. And then solve it for that x, which means if I'm getting this x by itself, I need to subtract 36 from both sides. So that's gone. All I'm left with is the 12x over here, 324 minus 36. Is 288. So now I need to divide both sides by this 12 to cancel the 12. So my x, I'm just going to have to write it over here, is going to be equal to, let's see, the left is 288 divided by 12, which gives me 24. Now, be careful though. That's telling me what the x is. The x is this side. What the question is asking is, what is the length of the ladder? This is the ladder, which means it's x, which is 24, plus 6, which is 30. So the length of the ladder would be 30. All right, number 8. Find the domain and write in an interval notation. So my function is f of x equals x minus 1 over x squared plus 7x. Now remember, the domain of a rational function, you're looking at the denominator. Because remember, the denominator of a fraction cannot equal 0. So I need to figure out what makes this denominator equal 0. Since it's squared, there's going to be 2 numbers. Okay, I can either put those in quad or they both have an x. So I'll just pull the x out, put in parentheses what's left. So it'll be x plus 7 equals 0. Then put your 2 factors. Those are what cannot equal 0. This one's already solved. So 0 is one of the values that I need to leave out of my domain. Subtract the 7's there. So x also can't equal -7. So they want us to show this in interval notation. So let's look at these numbers on a number line. If 0 is here, where would -7 be? It would be on this side of the 0, right? Here's my negative side. So in interval notation, I start at -infinity and I go to positive infinity, but I just need to leave out -7 and 0. So my first interval starts on the left with the -infinity, travels up until it gets to -7. Then you want to include all the numbers in between -7 and 0. So that's your next interval, numbers between -7 and 0. And then your last one is all the numbers above 0, which would be 0 to positive infinity. All right, number 9. All right, number 9 is a difference quotient problem, which the difference quotient is f of x plus h minus f of x all over h. And this one says to construct and simplify the difference quotient for this function. F of x equals 5x squared plus 7x. So the first part of the difference quotient says to go to your function and replace those x's with x plus h's. So let's see what that looks like. I'll have 5. Instead of x, I'll write in x plus h squared plus 7. I'm going to write in x plus h. So there's the first part. The second part of this numerator says to subtract the actual function exactly as it's written and put that in parentheses, because if not, if you don't put parentheses around that, you would just be subtracting that first term and not the 7x. Okay, so that second part is minus, and then just put the exact function in parentheses. Okay, we're going to worry about that h in the bottom in a little bit. Let's simplify this. The first thing I have to figure out is what is x plus h squared, which means I need to FOIL that. So my first x times x gives me x squared. My outer x times h gives me x h. My inner is actually another x h. And then my last h times h is h squared. But these two terms in the middle are like terms. And you have one here and one here. So you actually have 2 xh's. So that's what comes out of this right here, the x plus h squared. So I'm just going to bring down that 5. X plus h squared, just did that over here. So I have x squared plus 2xh plus h squared. So now to get rid of these parentheses, I'll distribute this 5. So 5 times x squared gives me 5x squared plus 5 times 2, so that gives me 10xh plus 5 times h squared, which gives me 5h squared. So that took care of this first part. Now the second parentheses, I need to distribute the 7 through there. So I have plus 7x plus 7h. And then I'll distribute the negative through that last parentheses, which is going to change both of those signs. So I'm going to have minus 5x squared minus 7x. And what happens when you change the signs of these terms in here? It makes them cancel something up front. So that negative 7x cancels out that positive one. And this negative 5x squared cancels out that positive one. So let's see what we are left with. I've got 10xh plus 5h squared plus 7h. Now think about the denominator, which is that h. But look at all the terms in the numerator. What do they all have in common? They all have an h in common. So I'm going to pull it out. Put in parentheses what's left, which will be 10x. If I took the h out, here, if I take an h out, I'm left with 5h. Plus here, if I take an h out, I'm left with the 7. And since my denominator is also an h, those h's cancel, and that is your answer. Number 10. Graph the function f of x equals the square root of x plus a. Again, if you know your shifting rules, that's an inside shift, which shifts it left and right, opposite the sign, which means it would shift the graph to the left a. If not, just go to your y equals, right? You have the graphing calculator. Here's your square root button right here. Since it's blue, I'll hit second square root, put in x plus 8, and graph it. So there's the square root shape, and it's moved to the left 8. Number 11. All right, number 11 is talking about relative maximum and relative minimum. Okay, so this point right here is your relative maximum. So let's look at its x and y coordinate. It's not left or right at all, so its x is 0 1. When you're talking about relative max and minimum, your max value is the y coordinate. So your max is 1, and it occurs at x equals 0. So the maximum is 1, and it occurs when x is 0. This is your minimum. So let's see, its x is 2. Its y is -3. So remember, the minimum value is whatever the y coordinate is. So the minimum is -3, and it occurs at x equals 2. All right, number 12. How can the graph of f of x equals -x minus 7 squared plus 8 be obtained from the graph of x squared? Okay, so you want to talk about the horizontal shift first, which is the inside number. So the first thing it's going to do is shift to the right 7, right? Because you go opposite the sign. So right 7. Then if there's a reflection, which means this negative, that's going to give it a reflection across the x axis. So that's what's next. So it reflects across the x. Okay, because of that. And then the vertical shift. The vertical shift comes, the up and down shift is your outside number. So my outside number is +8 when I go with that sign. So you would go up 8. So to the right 7 from the inside shift, reflects across the x-axis from this negative, and then shifts up 8 because of that outside number. All right, number 13, finding the zeros. You've got f of x equals 2x squared plus 11x plus 3. I'm finding zeros of a quad function. That just means, and I'm going to do it both ways for those that still don't have the quad function in their calculator. But if you do, you just go into the program button. I'm pretty much getting some free points. Go down to quad, enter, enter, and then typing in your A, B, and C. Remember, A is in front of x squared, so it's 2. B is in front of x, so it's 11. C is your constant, which is +3. It's going to give you a decimal answer first, and you won't see that in any of your multiple choice, but if you hit enter again, there is the two solutions, -11 plus and minus the square root of 97 over 4. Okay, if you don't have the quad program, you would have to use the quadratic function. I mean, the quadratic formula. Okay, so this is for those of you that do not have the quad program in your calculator. Let's see, my A, B, and C. A is in front of x squared, so it's 2. B is in front of x, so it's 11. And then C is your constant. We're going to replace the A's, B's, and C's in this formula with 2, 11, and 3. So let's see, the first thing I need is the opposite of your B. Well, the opposite of this would be -11, then plus and minus, then your square root. Then you need your B number again, but square it. So if I square 11, I get 121. Then minus 4. And then you're going to type in or put in your A and your C, which is 2 and 3. Your denominator is 2 times your A. Well, my A is 2. So the next step is to figure out what's underneath that square root. And so just type it in exactly like you see it. So 121 minus 4, open parentheses, 2, close, open parentheses, 3, close, enter. So that equals what's underneath the square root is 97. So negative 11 plus or minus the square root of 97 over your denominator, which is 2 times 2, gives you 4. So that one's not that bad of a if you don't have quad. All right, number 14, finding the vertex of a parabola. So f of x equals 2x squared minus 20x plus 5. Okay, I'm going to do it 2 ways. I'm going to put it in my y equals. So just go to y equals and clear it out again. Let's type it in, 2x squared. So 2x, then hit your x squared button. Uh-oh, not that one. So 2x squared minus 20x plus 5. And then graph it. Okay, so this is a good example to show of a good one to use another method, because what you're wanting to do, what did this make? It's a parabola. We just can't see the bottom of it, and we're looking for that point. The vertex is the point at which it changes directions. The way we did it in the calculator is from here we went to second calc, which is the trace button. And since that's the bottom of the parabola, I'm going to find the minimum. Now, the first thing is you want your cursor to be on the left side of the parabola. And there's my cursor, and it is on the left. So go ahead and hit enter. And then you want to put it on the right side. So you're just going to hit this right arrow until you can see the cursor over here. These. Oh, there it is. And hit enter again, because now I can see it on the right side. Hit enter twice. This guess, we don't need that. Hit it again. There is your vertex. So it's going to be at, this is essentially 5, negative 45. Is your vertex. The way to do it on paper is to find the vertex. The opposite of B over 2A will give you the x coordinate of your vertex. So let's see, what's the here's my B. So the opposite of it will be positive 20 over 2 times A, which is 2 times 2. So now I have 20 over 4, which is 5. So that gives you the x coordinate. Well, if you know the x, all you have to do is plug that x in here and here, and that'll give you the y coordinate. So let's see, if I do that, I have 2. Plugging in a 5 for my x. Squared minus 20 times 5 plus 5. So let's see, got to do my exponent first. first. So 5 squared is 25. So I have 2 times 25, which gives me 50, minus 20 times 5 is 100. Bring down that plus 5. Then if I go straight across, 50 minus 100 is negative 50, plus 5 gives me that negative 45. So again, that'll also, either way, it's going to give you the same thing. Number 15. Okay, number 15 says find the zeros of the polynomial function and state the multiplicity of each. So your zeros come from every factor that has an x. So what you want to do is go to all the factors that have an x, which are these two right here, and set them equal to 0 and solve them for x. So subtract 7s here. So x equals negative 7. And here add 7s to get x equals positive 7. So the zeros are negative 7 and positive 7. So now remember where the multiplicity comes. The multiplicity comes from the exponent of what that factor was. So this one's multiplicity is 2. And this one's multiplicity is 3. So negative 7 has a multiplicity of 2. Positive 7 has a multiplicity of 3. All right, graph this function. And again, it's multiple choice. So the first thing I want to think about is the end behavior. So let's see how many x's we would have. This would give me 2 because of the x squared. This would give me 2 more because of that x squared. So there's x to the 4th plus this one. So x to the 5th, and it's negative because of that negative right there. So what that tells me is that the end behavior, remember the 4 different types of end behavior. If your exponent was an even number, your end behavior would be the same. If it was even and positive, so if the exponent was even, but it's not, and that was positive, it's also not, that would be both going up. If your exponent was even, but the term was negative, they would be going down. The odd behaviors, if your exponent is odd, which this one is, but your term is positive, you're going to start at the bottom and end at the top, from the left to the right. And then opposite of that here. Here you're going to start at the top and end at the bottom if you're odd and negative, which is what this is, right? The exponent is odd, the term is negative, which means this one is going to start at the top and end at the bottom. Okay, that's going to give me down to, look at these 4 options. Look at C and B. They do the opposite of that. They both start at the bottom and then go up through the graph. Now D starts at the top and goes down, and so does A. Starts at the top and goes down. So I need to figure out something else. Since this is in factored form, let's think about what these mean. These are telling me where the graph has x intercepts. So let's see. I set each one of these equal to 0. Solve them for x. This one I'll divide both sides by -1, but that's still just going to be 0. Here, subtract 1 from both sides. So x equals -1. And add 4's here. So x equals 4. That's telling me where the graph is touching the x-axis. So you'll notice on A, it touches it at 1, 0, and -4. But D touches it. Oh, wait, hold on. Oh, sorry, +4. Sorry. Said that all the way wrong. So it touches it at exactly what those zeros are. -1, 0, and +4. Sorry, I'm looking at it backwards. So that's why it would be A. All right, number 17. Finding vertical asymptotes. Your vertical asymptotes come from zeros of the denominator that are not zeros of the numerator. So looking at 17, okay, luckily the denominator is already in factored form. So if I want to find the zeros, I just set the factors equal to 0 and solve them for x to get my vertical asymptotes. So here I would add the 3 to both sides. So x equals 3. And here subtract the 4 from both sides. So x equals -4. So those are your two vertical asymptotes. X equals 3 and x equals -4. Number 18. All right, f of x equals 2x minus 8, and g of x equals 9x squared minus 9x minus 7, and it wants me to find g of f of -6. All right, what you always find first is what is in this front position. So I am finding f of -6. Which tells me to go to my f function, so this front function, and replace its x with a -6. Okay, so if I replace this x with -6, I'll have 2 times -6 minus 8, which gives me -12 minus 8, which gives me -20. So once I get that, then I drop down this g, and you find g of whatever that last answer was. So I'm finding g of -20. Which means I will have, now I'm going to g and replacing its x's with -20. So I have 9 times -20 squared minus 9 times -20 minus 7. And you can type that whole thing just like that in your calculator. So if I do that, so 9, exactly what's on the board. Open parentheses, -20 close. Squared, so hit the squared button. Then -9, so -9, again, open parentheses, -20, close, -7. Enter, and that gives you your answer. So 3,770. Right, number 19. Is another composition of functions where we have f of x is -6x plus 8. And g of x equals 4x plus 3. And this time it wants me to find g of f of x. So I'm going to do the same. I'm going to start off the same way. The first thing I do is find f of x. Well, it tells me what f of x is. It's -6x plus 8. That's as far as I can go with that part, right? I can't do any math here. I can't put those together. So now, just like the last one, I'll drop down the g. And what do you find g of? Your last answer. My last answer is -6x plus 8. So this tells me to go to my g function and replace its x with what's in these parentheses. So I'll have 4. And instead of the x, I have -6x plus 8 plus 3. And then simplify that. So here, I'll distribute this 4. So 4 times -6x gives me -24x. 4 times 8 is 32. Bring down my plus 3. And then put together the 32 and 3. So -24x plus 35. All right, number 20, determine whether the function is 1-to-1 and then find its inverse. The function is f of x equals 3x minus 5. It is 1-to-1. It's going to be 1-to-1 because it's going to want you to find the inverse. The steps to finding the inverse. The first thing you do is change the f of x. What's the same thing as f of x? Y. Once you change the f of x to the y, then you invert the x and the y. Wherever you see a y, you put x. And wherever you see x, you put y. So this will turn into an x equals. This will turn into a y minus 5. And then solve it for y. Get your new y by itself. So add the 5 to both sides. So now I have 3y equals x plus 5, and then divide by 3. So y equals x plus 5 over 3. Number 21, graph the function f of x equals 4 to the x minus 3 plus 3. So again, another shifting one. This one, the inside number is here, the outside number is here. So that's going to shift it to the right 3 and up 3. So you may be able to just look at those. If not, go to your y equals and put it in. So 4. Then go up into your exponent and open the parentheses so you can type that whole thing in the exponent, that x minus 3. So x minus 3. Close it. Then hit this right arrow because you don't want to be up in the exponent anymore, right? To type in that plus 3, you want to be back down here. And then graph it. And that's it on that one. So it went right 3 and up 3. Number 22 gives me a log equation and then tells me to express it as an exponential equation. So this is what we just got through covering. Log base 6 of 36 equals t. So it just wants me to convert this into an exponential equation. Remember, the base of your log is going to be where you start. That's going to be the base of your exponent. It's going to be raised to that power, so 6 to the t power, and then that's going to be equal to 36, whatever's in that position. It doesn't want you to solve for t. It just wants you to convert from the log equation to the exponential equation. (23) All right, express in terms of sums and differences of logarithms. So we've got log x to the 9th, z over y to the 3rd. Again, this is out of the section that we just covered. Remember, the numerators, when I put this into multiple logs, it's going to be plus the numerators and then minus the denominator. So let's see, the first thing I'm going to have is log, my first numerator is x to the 9th plus log, the next one is z, then your denominator. So since it's in the bottom, that's going to be minus log y to the 3rd, and then drop down those exponents. So this one will be 9 log x plus drop down the log z minus drop down the 3 log y. Two more. All right, the population of a small country increases according to the function, and it gives you the function. B equals 1,200,000 E to the 0.04 t, where t is measured in years. How many people will the country have after 4 years? Where do your years go? In the t spot. So you're just replacing that with a 4. So 1,200,000 E to the 0.04 times 4, and that goes in your calculator. So 1,200,000 E, so second, and then your ln button gives you your E. And then type in the exponent exactly how you see it. So 0.04, open parentheses, 4, close it. Oh, we just need it just rounds it. So 1,408,213. So it's just rounded to the nearest person. All right, last one. Solve the exponential equation. Five to the 6 minus 2x equals 25. Now remember, the easiest kind was when I can rewrite this side to have the same base as this. So let's use 5 as our base and see if we can get to 25. So 5 to the first power is 5. But what is 5 squared? It is 25. So that's good news because I can just simply rewrite this side as 5 squared. Bring this down. Then all you do, if you can make these bases the same, is make an equation out of your exponents. So 6 minus 2x equals 2. And then solve it for x. So subtract the 6 here. So negative 2x equals negative 4. Divide by negative 2. So x equals 2. Okay. All right. So that is your final exam review.